see vector A and a bar is put over it. Average acceleration is change in velocity by time interval, delta V by delta t. And we already studied vector V is Vx I cap plus Vy j cap. That we have to substitute in the place of vector V, we have to substitute this one. So after substituting delta V in the place of V, what we have to substitute? Vx I cap plus Vy j cap. Okay, that is substituted here. Next step, we are splitting the two terms. That means delta Vx I cap by delta t plus delta Vy by delta t into j cap. We just splitted this into two terms. So this is the I component, this is the j component. And we know delta Vx by delta t, that is Ax, x component of acceleration, and delta Vy by delta t, that is y component of acceleration. Velocity, change in velocity by time, that is acceleration. And here x is written, that means x component of acceleration. Change in velocity by time, that is acceleration. And here y is written, that means y component of acceleration. So we can write vector A bar is equal to average acceleration equal to Ax I cap plus Ay j cap. Next step is to find the limiting value. When we give the limit to the average velocity, we get the instantaneous acceleration. So what is instantaneous acceleration? Limit delta t tends to 0, delta V by delta t. This we have studied in one-dimensional motion in a straight line. This equation we already studied. So with just what change you have to make here? In the place of vector V, you have to write the component form. Delta in the place of V, Vx I cap plus Vy j cap. Next step, splitting the two terms, I cap into limit delta t tend to 0, delta Vx by delta t plus j cap into limit delta t tend to 0, delta Vy by delta t. And we know this is dVx by dt, delta Vx by delta t, limit delta t tend to 0, delta Vx by delta t, that is dVx, first derivative of the x component of velocity, dVx by dt, plus j cap into dVy by dt, first derivative of velocity along the y direction. What is dVx by dt, children? Chandana, what is dVx by dt? What is dV by dt? dV by dt.
Derivative of the component x.
dV by dt we have studied. What is it? What we have studied dV by dt? First, in motion in a straight line we studied dV by dt. Instantaneous acceleration. Clear? And here x is written. So it will be component of instantaneous acceleration along the x direction. Component of instantaneous acceleration along the x direction. Ax I cap plus Ay, like this we are getting. Ax I cap. See, dVx by dt is Ax I cap plus Ay j cap. So then the next is to find the direction. So what is the magnitude, children? What is the magnitude of acceleration? Equation we got, component form, Ax I cap plus Ay j cap. So what is the magnitude of acceleration? Magnitude of acceleration, I will ask to Parvati, what is the magnitude of acceleration? Magnitude of acceleration, Parvati. What is the magnitude of acceleration? This is the equation for acceleration when body move in a plane and body in two-dimensional motion. This is the equation for acceleration, instantaneous acceleration. How will you find the magnitude? That is the question. Magnitude finding equation? Don't know?
I can't remember.
Okay, then I will ask Arjun, what is the magnitude of acceleration?
Root V x plus
Ah,
vy
V1 ഇവിടെ A അല്ലേ?
ax square plus ay square.
Correct answer. Root of ax square plus ay square. Just as we have done for velocity, root of vx square plus vy square. Just like that, we have to write the magnitude of acceleration is root of ax square plus ay square. Then we should know the direction of acceleration also. And we know the acceleration is change in velocity by time. So what will be the, from this equation, can you tell what is the direction of acceleration from this equation? Who will tell? Aishwarya, yes. From this equation, average acceleration is delta v by delta t. What is the direction of acceleration? Aishwarya?
Yes, teacher.
What is the direction of acceleration? See, acceleration equation is change in velocity by time. So what will be the direction? This is a vector quantity. Velocity is a vector quantity. So acceleration direction will be in the direction of. Answer is there inside this. Acceleration is change in velocity by time. Velocity എങ്ങോട്ടാണോ change ചെയ്യുന്നത്? Change in velocity by time. So what is the direction of acceleration? Anyone? Anyone can tell. Direction of? Bhagat?
Direction of velocity.
Direction of change in velocity. Okay. Direction of change in velocity. Acceleration's direction is in the direction of change in velocity. Change in velocity is direction. That is the direction of acceleration. Okay. Let us see that. Okay.
That is, in the limit delta t tends to 0, the average acceleration becomes the instantaneous acceleration. Now, let us understand graphically the limiting process.
Okay, now we are going to find the direction of acceleration. So, here yellow curve represent motion of the body. So, body is moving like this, arrow mark is shown. And how will you find the direction of acceleration? For that, you have taken 2 points P and P1. And you have drawn the tangent at P and P1. The green line, tangent. Tangent represent the velocity. So, initial velocity. When body is at P, vector V is the velocity. Direction is shown by drawing the tangent at that point. And when it is at P1, again draw a tangent at that point. And that gives the direction of velocity. When it is at P1, V dash, vector V dash is the velocity. Now, velocity change, how will you find? How will you find change in velocity? For that, you are representing a point here and marking velocity vector v. Parallel to this velocity, we draw a vector v here. Parallel to this velocity, we draw a vector here. See, vector v dash represented here. Taking a point here, we have represented both vector v and vector v dash. Now, velocity is changed from P to V dash. So, we have to draw a line joining vector, this tip of this vector V to tip of the vector V dash. That will represent change in velocity. So, change in velocity's direction is like this. That is acceleration. Acceleration is acting like this. So, this is giving the direction of change in velocity, and that is same as the direction of acceleration. So, when a body is moving like this, acceleration is acting on the body in this direction. Acceleration. Due to that acceleration, the body is moving in this direction because of this acceleration. So, it is accelerated. So, change in velocity gives the direction of acceleration, and you can see that
in defining acceleration or the instantaneous acceleration. This graph actually shows the path of an object which is in motion in the xy plane. So here we have the x-axis, here we have the y-axis. Actually this yellow line or this yellow curve actually shows the path of the object which is moving in this xy plane. And here this P actually represents the position of the object at a particular time t. and this P1 is the position of the object after some time delta t. That is, for example, when t equal to 5 seconds, the object has reached here. You just imagine. Then after 10 seconds, the object reached here, like that. Okay, delta t is the time duration between these 2 points. T is the time, and at that time the object is here at the point P, and after some time delta t, the object has reached here at this point P1. Okay, the object moves along this path, and we know that the direction of velocity of the object at a particular point will be along the tangent to that point, which we have discussed in our previous video. Okay, so here we have the position of the object at this point P at a particular time t. So the velocity, its velocity, to get the velocity, direction of velocity, we just want to draw a tangent to which is a tangent which is passing through this point. And to get the direction of velocity, here we have taken the velocity as vector v. Okay, then at this particular point, to get the direction of velocity, we again want to draw a tangent here at this point. So just imagine this as the tangent at this point. So we are getting the direction of velocity of that object at this particular point P1, and we have taken that velocity as vector v dash. Okay, so here you see we have vector v along this direction, and we have, that is, here I have drawn those two vectors separately. Okay, here we have this vector v along this direction, and we have this vector v dash along this direction. Right, vector v dash, that is what we are doing is we are just moving this vector v dash in such a way that its tail is at the tail of vector v. Then I have just joined these two vectors by another vector like this. Okay, let this vector be vector x. Okay, here we have two vectors, one is vector v, another one is vector v dash. I have just moved.
Okay, children, so we got that this is actually the change in velocity.
We can move these vectors, these are parallel. Okay, now
this is actually change in velocity. Understand? So these are in the triangle of vector addition, vector v plus delta v equal to v dash, or vector v dash, final velocity minus initial velocity, that will give change in velocity. Okay, so change in velocity gives the direction of acceleration. That is what we are seeing. And instantaneous acceleration, let us see instantaneous acceleration. Instantaneous acceleration means time interval we have to reduce to 0. Time interval reduced to 0. That means first we have taken this much time interval delta t. Then later we have taken 2 points very nearby points. Then delta v direction you see. Here you see vector v, vector v. Vector v dash, vector v dash. Direction. Change in velocity is direction is marked. Again taken 2 nearby points. There also we have represented vector v, vector v dash, change in velocity. You have to notice the direction of change in velocity is changing. Change in velocity direction is changing. And direction is changing. And next instantaneous, how they find, we can see instantaneous. This is the way to find instantaneous velocity. See, the again time interval reduced to P to P3, again reduced, time interval reduced to 0. We get the instant. Instead of interval of time, we get an instant of time when time interval tends to 0. So at that time you see the angle between velocity and acceleration. Here by drawing the tangent we give direction of velocity, and here acceleration is in the direction of change in velocity. And acceleration is in the direction of change in velocity. So it is like this. So it can have any angle between velocity and acceleration, can have any angle between 0 and 180 degree. But you know, in one dimension motion, a motion in a straight line, velocity and acceleration are having only two angles. One is in the same direction of motion or in the opposite direction of motion. For example, a body, suppose when we throw a body upwards, motion of the body upwards, acceleration due to gravity downwards. So what is the angle between motion of the body and gravity when body moves upwards? Motion upwards, and acceleration downwards. Motion upwards, acceleration downwards. What is the angle between them? Dhanush, what is the angle between them? Motion upwards, gravity, acceleration due to gravity downwards. What is the angle? Dhanush? No answer. Hemal Krishna, what is the angle? Body moving upward, gravity downwards. What is the angle? Hemal Krishna? Huh? Body moves upwards. Body upwards. Gravity downwards. Appa endayirikkum angle?
180 degree.
180 degree. Correct answer. When body move downwards, gravity downward. What is the angle? Body downward, gravity downward. What is the angle?
0.
0. In that case, it is 0. Correct answer. So, either 0 or 180. Only two cases are there. When body move in one dimension, that is motion in a straight line, angle between velocity and acceleration can be either 0 or 180 degree. But you know, in two dimension, here we are discussing two dimension, velocity's direction and acceleration's direction can be any value between 0 and 180. It can take any value between 0 and 180. Okay, children? That is, so in order to explain that, we have considered all these figures. Direction of acceleration or angle between velocity and acceleration can have any value between 0 and 180. Okay. Okay, then I'll explain with the notes. So acceleration vector, instantaneous acceleration is limit delta t tend to 0, delta v by delta t, but v equal to vx I cap plus vy j cap. That is substituted here. Then limit is given to both the terms. Then delta vx by delta t, change in velocity by time along the x direction, dvx by dt. Change in velocity along the y direction, rate of change of velocity, that is acceleration along the y direction. So that is written as ay. So we can write ax I cap plus ay j cap. So this is the expression for instantaneous acceleration. Ax I cap plus ay j cap. What's the magnitude of acceleration? Root of ax square plus ay square. Just like we did for velocity. Here also the acceleration is having the magnitude root of ax square plus ay square. And direction, in order to that can be any value between 0 and 180. Acceleration can take any value between 0 and 180. Okay. So that is written in here. Then it is problem. Problem we can discuss later. Now, equations of motion. When a motion in a plane with constant acceleration. See children, now we have to study problems more. Because first term, our exam is multiple choice questions, assertion, reason, and case study question, etc. will be there, multiple choice questions. And more importance is to be given to the equations. What it represents, what this equation, when you get one equation, you should know what is vector v, what is vector v0, what is a, what is t, all letters, what they represent, you must know. Derivation is not needed, but concept you must be clear. So that's why we are explaining derivations, because you should have a clear concept. Conceptual questions also will be there. Concept should be clear. So derivation no need to study by heart. That's all that's you have to do. No need to study no need to by heart the derivation. That is there, but you know, problems, give importance to problem here onwards. Okay, and for that you should know all the equations. Okay, so anyway you have to understand the steps. No need to by heart, but or the final expression you should know. Suppose I am asking, but the same equation we have studied in one-dimensional motion. V equal to V0 plus AT. This equation we have studied in one-dimensional motion. And here we are writing in component form. See, motion in a plane. Just when you see this, motion in a plane with constant acceleration, we have to express all the letters, all the vectors used in component form. That is the only difference. This we have studied, this equation we have studied, vector V equal to V0 plus AT, that we have studied. But when we study motion in a plane, what is the difference? We have to express in component form. What is the component? Well, final velocity vector V equal to, final velocity vector V equal to initial velocity vector plus acceleration vector into time V equal to V0 plus AT. We just put the vector symbol over the vector quantities. Children, this equation you have studied last chapter, velocity time relation, isn't it? Isn't it, children?
Yes, teacher.
This equation we have studied, but the only difference, we are going to write all these vectors in component form, x and y component. That's the only difference. So we are going to write in component form in terms of components. Vector V, final velocity vector V, Vx x component, Vx I cap plus Vy j cap. Similarly, initial velocity is also having x and y component. So V0 x I cap plus V0 y j cap. Similarly, acceleration also we have studied in component form, Ax I cap plus Ay j cap into, that is inside the bracket, into t. T is there. So this equation we already studied in one-dimensional motion, but when we study two-dimensional motion, what's the difference? All the vector quantities expressed in component form. So that is done here. See, we have written in component form. Next step, we are taking x component separately. We are taking y component separately. Next step is that. So from this x component you have to take, okay, I will ask to Jaidar, take x component from this equation. Jaidar, take x component matram parna madi. Tell x component only. Jaidar, are you there? Jaidar? Undo, Jaidar. Not see. Ayush, tell. Ayush, take x component and tell. One equation we got with x and y component. Next, you have to take only x component. Left side, what is the x component of velocity? Ayush? ഇവിടെ നോക്കിയിട്ട് പറ, എക്സ് കമ്പോണന്റ് വെലോസിറ്റി എന്താണ്? ഇവിടെ ഇവിടെ എഴുതിയിട്ടില്ലേ, എക്സ് എന്ന് എഴുതിയിട്ടില്ലേ? വി എക്സ് കണ്ടാ, അതാണ് എക്സ് കമ്പോണന്റ് വെലോസിറ്റി. വൈ കമ്പോണന്റ് വെലോസിറ്റി എന്താണ്? വി വൈ. വി വൈ കണ്ടാ. അപ്പൊ വി എക്സ് ഐ ക്യാപ് പ്ലസ് വി വൈ ജെ ക്യാപ് എന്നാണ്. ഇനി അതുമാതിരി അപ്പൊ നമ്മൾ അതിൽ എക്സ് മാത്രം എടുത്തു, വി എക്സ് എടുത്തു, ഈക്വൽ ടു. ഇനി ഇതിൽ പറ, ഇനീഷ്യൽ വെലോസിറ്റിയിൽ എക്സ് കമ്പോണന്റ് പറ ആയുഷ്. ഇനീഷ്യൽ വെലോസിറ്റിയിൽ ഇതാണ് ഇനീഷ്യൽ വെലോസിറ്റി, അതിൻ്റെ എക്സ് കമ്പോണന്റ് ഏതാ? എക്സ് എന്ന് എഴുതിയിട്ടുണ്ടാവും, അതാണ് എക്സ് കമ്പോണന്റ്. ഏതാണ്? V0 ആണ്. ഇനീഷ്യൽ വെലോസിറ്റിക്ക് നമ്മൾ V0 എന്നാണ് പറയുന്നത് കേട്ടോ, ഓ അല്ല കേട്ടാ, V0. അപ്പൊ V0 എക്സ്. അപ്പൊ ആ ഇനീഷ്യൽ വെലോസിറ്റിന്ന് അതിൻ്റെ എക്സ് കമ്പോണന്റ് മാത്രം എടുത്തു, V0 എക്സ് പ്ലസ്. ഇനി ആക്സിലറേഷൻ ഹിയർ A ഇൻറ്റു ടി, അതിലും ഉണ്ട് എക്സ് കമ്പോണന്റ്. ഒന്ന് പറഞ്ഞേ, വാട്ട് ഈസ് ദ എക്സ് കമ്പോണന്റ് ഓഫ് ആക്സിലറേഷൻ? വെക്ടർ പറയണ്ട, എക്സ് കമ്പോണന്റ് മാത്രം പറഞ്ഞാൽ മതി. പറ ആയുഷ്. രണ്ടും കൂടി പറയണോ? ഇത് വൈ അല്ലേ? X component മാത്രം പറയാൻ പറയുമ്പോൾ AX ഇവിടെ ഇൻറ്റു ടിയും കൂടെ ഉണ്ട് അതും കൂടി പറ AX tell
AXT.
AXT അപ്പം ഐ കമ്പോണൻ എല്ലാത്തിൻ്റെ ഐ കമ്പോണൻസ് മാത്രം എടുത്ത് അതായത് ഐ വരുന്ന ടേംസ് മാത്രം എടുത്തു ഐ മീൻസ് ഇറ്റ് ഈസ് അലോങ് എക്സ് ആക്സിസ് സോ വി എക്സ് ഈക്വൽ ടു V0x plus AX into T. Similarly, Y component, you can take, Arjun tell, taking the Y component. Taking the Y component, tell what is the Y component of velocity? What is Vy equal to initial velocity, the Y component, what is it? Velocity, initial velocity is Y component.
V0y.
V0y. Then acceleration Y component.
AYT.
Y into T, correct. So when we take motion or when we consider motion in a plane, velocity is having two components. Vx, how will you find accelerated motion? This is V0x plus AX into T. Vy, how will you find V0y plus AY into T. So all we are taking in component form. That's the only difference. This, see, now you can tell from this equation itself you can tell. This is the equation what we have studied. Final velocity equal to initial velocity plus acceleration into time. Now, if I am asking you to tell the x component, what will you tell? Vx equal to V0x plus AX into T. Now, I ask you to tell what is the y component of velocity. What will you tell? Just by looking this, you can tell. Okay, I will ask to Deepa, tell the y component of velocity, final velocity from looking this equation. Tell the y component of velocity. Deepa.
Teacher.
Tell the y component of velocity looking this equation. Y component of velocity.
Plus
Vy equal to what will be here? V0y plus
YT.
AY into T. Very good. That's the way to tell x component and y component. So just you are knowing this equation. This equation you are knowing. X component of velocity Vx equal to V0x plus AX into T. Y component of velocity Vy equal to V0y plus AY into T. That's all. So like that we have written the components. Why we are writing in component form? Because when body move in a plane, velocity will have both components. That's why we are studying all this. Velocity, acceleration is having two components. Displacement is also having two components. So in component form, we have to express all the equation we have studied. Here also we have studied this equation S equal to ut plus half at square S or r minus c. Here displacement time relation in two-dimensional motion. Displacement. So initially position is r0. Body moved with an acceleration. Finally it reached to position r. For example, initially Chandrapini. Finally at Adamutta. Like that, position vectors are given. Chandrapini and Adamutta. What is the displacement? Final position Adamuttam minus initial position Chandrapini, vector r minus r0. That is the displacement vector. How will you find? That is average velocity into time. Uniform acceleration if body is moving. Body is moving with uniform acceleration, not at all changing acceleration. Acceleration is uniform, constant acceleration it is changing. So average acceleration into time. That means displacement. So r minus r0, final position minus initial position equal to average velocity into time. And average velocity, how will you substitute? See, average final velocity we have studied V0 plus AT. V equal to U plus AT, that formula V0 plus AT plus again V0 is there, V0. Next step, V0 plus V0, 2V0 by 2 into T. plus half at into t, half at square. So r minus r0 equal to 2 cancel, v0 t plus half at square, s equal to ut plus half at square, same thing. Now I am asking you to write all the vectors in component form. All the vectors in component form. Vector r equal to final position. Final position vector, vector r equal to r0 taken to right side. So, right side of the equation. So, vector r0 plus, this is taken to right side of this equation. So, becomes plus. So, vector r0 plus v0 into t plus half a into t square. Now, I am asking you to write this in component form. So, I will ask question now. Children, I am no, you have to split in your mind. R equal to xi cap plus yj cap. R0 equal to R0 xi cap plus R0 yj cap. V0 xi cap plus V0 yj cap. Similarly, acceleration ax I cap plus ayj cap. I will show you. Okay, next, how it is split, we can see. See, that is splitted in component form. See, r equal to r0 plus v0 into t plus half a into t square. This is the equation we are having, and we are writing in component form. Position vector xi cap plus yj cap, initial position vector x0 I cap plus y0 j cap, velocity vector initially v0 x I cap plus v0 y j cap into t plus acceleration vector half a t square, half into, in the place of a we have to write the component form ax I cap plus ayj cap into t square. Okay, now we have expressed this equation in component form. See children, everybody should be able to write like this. See the difference I will tell when you write these quantities. Difference. Position vector always expressed xi cap plus yj cap, r0 x0 I cap plus y. We are not writing rx I cap plus ry j cap. We are not writing, children. That you have to see how we are expressing position vector. Only xi cap plus yj cap. R0 x0 I cap plus y0 j cap. We are not writing rx I cap plus ry j cap. R0 x I cap plus R0 y j cap. We are not writing like that. That you have to be careful. Position vector always written xi cap plus yj cap. Position vector x0 I cap plus y0 j cap. But we know velocity vector v0 x I cap plus v0 y j cap. Acceleration vector ax I cap plus ay j cap. Like that it is written. That is the difference. While splitting the vector, that difference you must know. Next, I am asking you to write the components. Okay, I'll ask question. Muhammad Nidal, tell x component, all the x component, tell Muhammad Nidal, tell all the x components. ഇവിടെ നെക്സ്റ്റ് ഉള്ള ടേം പറയാ, ഇവിടെ ഉള്ള എക്സ് ടേം പറയാ, ഇവിടെ ഉള്ള എക്സ് ടേം പറയാ, ഇവിടെ ഉള്ള എക്സ് ടേം പറയാ. നിദാൽ, are you there? റഹാൻ ഇല്ല. പാർത്ഥിവ്, നിഹാൽ ഇല്ല. എന്നാരോടാ ചോദിക്കാം? ആരും ആരാണ്? പാർത്ഥിവാണോ? നിഹാൽ. നിഹാൽ ടെൽ all the x component take and tell x equal to, ഇവിടെ x എടുക്കാം. x equal to ഇവിടെ എന്തെടുക്കണം? പറ, x ഉള്ള കമ്പോണൻസ്. നിഹാൽ, x0 പ്ലസ്
x0
ഇവിടെയോ v0 x into t പ്ലസ് ഇവിടെയോ half ax
T square.
ടി സ്ക്വയർ വെരി ഗുഡ് അതുമാതിരി വൈ പറഞ്ഞ വൈ ഈക്വൽ ടു വൈ ഈക്വൽ ടു പറ
Y0
പ്ലസ് ഇവിടെ
plus V0
y
Y
ഇൻറ്റു
into T plus
Plus
half
half
Y T square.
Very good. This is the component, very important equation. X component and Y component. S equal to ut plus half y t square. Its component form is this.